Welcome! Today we are going to be exploring population dynamics and competition in ecosystems using the PhET Natural Selection simulation. In this activity, we are going to investigate how different environmental factors, like limited food and predators, affect the size of a rabbit population over time. Let's get started by opening the simulation. Go to phet.colorado.edu/simulation/natural-selection. Once it loads, click the play button and make sure you are on the Intro tab on the left. Now, before we do anything else, this is really important. For this entire activity, we are leaving all mutations unselected. That means do not click on any of the fur color mutations. We want all of our bunnies to look the same, so we can focus on how the environment affects the population, not their traits. Now let me show you the two tools you will be using throughout every challenge. The first tool is the data probe. Click the words data probe on the left side of the screen. Click and drag the vertical line over the population graph and you can see the exact number of bunnies at any point in time. You will need this to answer questions about carrying capacity and population size. The second tool is the orange restart button. You will see an orange circle in the bottom right corner of the screen. You will use this to restart the simulation at the beginning of each new challenge. Make sure to use this every time as it resets everything cleanly. Pause here. Find the data probe and the orange restart button on your screen before moving on. Let's begin Challenge 1. First, click the restart button if you haven't. Next, click Add a Mate. This will add a second rabbit so your population can start growing. Now wait and watch the population grow until you reach Generation 3. You can see the generation number on the population graph at the top of the screen. We are at Generation 3 now. On the right side of the screen, find the environmental factor called limited food and click it to turn it on. Make sure your data probe is also turned on so we can track the exact numbers. Now let's keep watching together until we reach Generation 5. If the graph looks too zoomed in, feel free to click the minus button to zoom out and see the full population over time. Here we are at Generation 5. I am going to pause the simulation here so we can take a look together. Here is our first question. During Generations 1 through 5, what happened to the size of the population of bunnies? Take a moment to look at the graph. You should notice that the population grew pretty quickly at first. This makes sense. In the early generations, there are only a few bunnies, so there is still enough food for everyone. The population has room to grow. The population climbed all the way up to 312 bunnies and then dropped back down to 95. That is a huge change. The population grew very quickly at first because there were only a few bunnies and enough food for everyone. But once the population got too large, there was not enough food to go around. Now let's unpause and keep watching for a few more generations. Notice something interesting is starting to happen. The population goes up, then comes back down, then goes up again over and over in a wave pattern. Here is our second question. Why does this keep happening? Think about the limiting factor. Limited food. When the population gets very large, there are too many bunnies competing for the same food. Not everyone gets enough to eat, so some bunnies die and the population drops. But once the population gets smaller, there is enough food again, bunnies start reproducing, and the population climbs back up. Then the cycle repeats all over again. This is nature's way of keeping the population in balance. Now here is our third question. Under these conditions, will this population ever completely die out? The answer is no. As long as limited food is the only environmental factor, the population will keep fluctuating up and down, but it will never completely disappear. There will always be enough survivors to keep reproducing. Now let's find the carrying capacity. I am going to use the data probe and hover over the highest points on the population graph. You can see that the population peaks at different points. It is not always the exact same number, and that is completely normal. In nature, carrying capacity is not a perfect fixed number. It is more of a range. So for this simulation, we can say the carrying capacity is approximately 300 bunnies, with the highest peak reaching 313. Great work completing Challenge 1. Before we move on, take a moment to make sure you have written down all of your observations for Challenge 1. That includes your answer about what happened to the population in generations 1 through 5, why the population keeps fluctuating up and down, whether the population will ever die out, and the carrying capacity number. Pause the video here if you need more time. Ready? Now let's begin Challenge 2. Click the orange restart button in the bottom right corner to reset the simulation. Click Add a Mate and watch the population grow until we reach Generation 3. We are at Generation 3 now. This time, on the right side of the screen, select the environmental factor called wolves. Make sure the data probe is turned on. Now watch what happens right away. I am going to pause here so we can take a look together. Here is our first question. Right away after adding wolves, what happened to the size of the population? You can see the population dropped from 162 bunnies all the way down to just 18. That is a huge drop in a very short amount of time. The wolves are actively hunting the bunnies, so the population falls dramatically. Now here's our second question. Under these conditions, will this population ever completely die out? Let's keep watching the simulation. All of the bunnies have died. You can see that by Generation 8, the population reaches 0. All of the bunnies have been eaten. Unlike the limited food challenge where the population kept bouncing back, wolves are such a powerful predator that they can wipe out the entire population completely. Now let's try something different. Click the orange restart button again. This time let the bunnies grow all the way to Generation 6 without adding any wolves. You can speed up the animation by clicking the fast forward button to move things along more quickly. Watch what happens when there are no predators present. You can see the population has exploded, and the simulation is telling us that the bunnies have taken over the world. With no wolves and no limiting factors, nothing is stopping the population from growing out of control. Now let's find the carrying capacity. Click the minus button to zoom out so we can see the full graph together. Use your data probe and hover over the highest point on the graph. You can see the population reaches a maximum of 1,428 bunnies before the simulation stops it. So the carrying capacity under these conditions, with no limiting factors, is 1,428 bunnies. Great work completing Challenge 2. Before we move on, take a moment to make sure you have finished writing down all of your answers for Challenge 2. There is no rush. Pause the video here if you need more time. Ready? Let's begin Challenge 3. Click the orange restart button in the bottom right corner to reset the simulation. Now before we add a mate, we need to change the environment. Look for the environment toggle in the upper right corner of the screen. Click the snow button and switch from desert to Arctic. You will see the background change from sand to snow. Now click Add a Mate and watch the population grow until we reach Generation 3. You can use the fast forward button to speed up time. We are at Generation 3 now. On the right side of the screen, select the environmental factor called wolves. Make sure the data probe is turned on. Now here is something important to notice before we watch. In the Arctic environment, the bunnies are white. White bunnies blend in with the snow, making it harder for wolves to spot them. Here is our first question. Because white bunnies blend in with the snow, do you think they get eaten by wolves more often or less often? Take a moment to think about it. Resume the video when you have an answer. The answer is less often. Because white bunnies camouflage with the snow, wolves have a much harder time finding them. This gives the white bunnies a survival advantage in this environment. Now let's watch what happens to the population. I am going to pause here so we can take a look. Here is our second question. Under these conditions, will this population ever completely die out? Take a look at the population graph. You can see that even with wolves present, the population keeps trending upward over time. So the answer is no. In the Arctic environment, the white bunnies blend in so well with the snow that the wolves cannot eat them fast enough to wipe out the whole population. The bunnies have a strong survival advantage here. Now here is something the simulation might tell you. If it says bunnies have taken over the world, that is an extreme example of overpopulation. But in real life, that would never actually happen. What would more likely happen if there was a huge population of bunnies in the real world? Think about it for a moment. In reality, a booming rabbit population would quickly run out of food, space, and other resources. Other predators would also move in to take advantage of the large food supply. Nature has many ways of bringing populations back into balance. Now, you might also notice that in this simulation, wolves do not appear constantly. They only show up every once in a while. Here is our next question. Why do you think that is? There are actually two reasons. First, in real ecosystems, predators do not hunt every single minute of every day. They hunt when they are hungry, and they rest when they are not. This is what the simulation is trying to show us. Second, remember that in the Arctic, their white fur blends in with the snow, making it much harder for wolves to spot them. So even when wolves are hunting, the camouflage makes the bunnies harder to find. Now let's look at death rate at Generation 4. Use your data probe and you can see the population is at 103 individuals. Watch carefully as the wolves come in. I am going to pause here right after the wolves visit. You can see that after the wolves eat, there are 65 bunnies remaining. That means 38 bunnies were eaten in this generation. Now let's calculate the death rate for Generation 4. The death rate tells us what percentage of the population was lost. We started with 103 bunnies. We lost 38. So we divide 38 by 103 and multiply by 100. That gives us a death rate of approximately 37% for Generation 4. That means wolves wiped out about 1/3 of the entire population in just one generation. Great work completing Challenge 3! Before we move on, take a moment to make sure you have written down all of your answers. That includes whether the population will die out, why wolves only appear every once in a while, and the death rate for Generation 4. Pause the video here if you need more time. Ready? Let's begin Challenge 4. This is our final challenge. Click the orange restart button in the bottom right corner to reset the simulation. Make sure your environment is still set to Arctic. You should see the snowy background. If not, click the environment toggle in the upper right corner and switch it back to Arctic. Now click Add a Mate and watch the population grow until we reach Generation 3. We are at Generation 3 now. This time we are going to add both environmental factors at the same time. On the right side of the screen, select Wolves and Limited Food. Make sure your data probe is turned on. Now let's watch what happens. Here is our first question. Under these conditions, will this population ever completely die out or overpopulate? The answer is neither. Look at the graph. The population keeps fluctuating up and down, but it never crashes to zero and it never explodes out of control. Having two limiting factors working together, wolves and limited food, creates a much more stable and balanced population than either factor alone. Moving on to our next question, what is the average birth rate? Now let's look at the numbers more carefully using the data probe. You can see the population peaks at around 324, 306, and 313, and drops down to around 102, 105, and 94. Here's our second question. What is the average birth rate? To calculate the birth rate, we look at how much the population grows from its lowest point to its highest point. For example, the population grew from 102 all the way up to 306. That means 204 bunnies were added. We divide 204 by 102 and multiply by 100. That gives us a birth rate of 200% for that cycle. Looking across all our cycles, the average birth rate is approximately 197%. That means the population doubles during each growth phase. Now, what is the average death rate? To calculate the death rate, we look at how much the population drops from its highest point to its lowest point. For example, the population dropped from 324 down to 102. That means 222 bunnies were lost. We divide 222 by 324 and multiply by 100. That gives us a death rate of approximately 69% for that cycle. Looking across all our cycles, the average death rate is approximately 67%. That means about 2/3 of the population is lost during each decline phase. So even though the population loses 2/3 of its individuals during each decline, it nearly triples back during each growth phase. This is what keeps the population stable over time. Here is our third question. Is this simulation more or less realistic than the previous challenges? This simulation is actually more realistic. In the real world, ecosystems almost never have just one limiting factor. There are usually multiple pressures acting on a population at the same time, just like we are seeing here with both wolves and limited food working together. Now here is our fourth question. What is an abiotic or non-living component of this ecosystem? Look around the simulation. The snow and ice in the Arctic environment are great examples of abiotic factors. They are non-living parts of the ecosystem that still affect how the population survives and behaves. Now let's find the carrying capacity. Use your data probe and hover over the highest points on the graph. You can see the population reaches a maximum of approximately 324 bunnies under these conditions, so the carrying capacity with both wolves and limited food is around 320 bunnies. Great work completing all 4 challenges. You have explored how different environmental factors like limited food and predators affect rabbit populations, learned about carrying capacity and limiting factors, and even calculated birth and death rates. That is a lot of great science. Take a moment to make sure you have written down all of your observations and answers before closing out. Thanks for following along, and great job today.